Okay, on the unit 2 review, the first set is on our counting principles. So this would be when we multiply, combinations, permutations, factorials. So it says you are at a restaurant, which allows you to select one from each of the following. So it's one from each category, so you're going to multiply your options together. You have a choice of 5 different soups or salads, 3 different entrees, 4 different desserts, and 6 different beverages. This comes out to 360 different options. Number 2, how many possible outcomes are there when you flip a coin 6 times? Well, in the first toss, you have 2 options, heads or tails. Second toss, 2 options, heads or tails. Third toss, 2 options, heads or tails. Fourth toss, 2 options, heads or tails, all the way to your 6th toss. It's 2 to the 6th, which is 64. This would be similar to asking how many possible outcomes are there when you roll a die 4 times. That would be 6 times 6 times 6 times 6. Number 3, a school's ID system gives every student a different ID code. Each code consists of 2 letters followed by 4 numbers. A, find the possible outcomes when repetition is allowed. Okay, so we have 2 letters followed by 4 numbers. Your letters, you have 26 options for each. For your digits, there aren't any restrictions. There's nothing that says the first digit can't be 0 or the last digit needs to be odd, and we're allowed to repeat. We get 6,760,000 possible ID codes. Part B, repetition is not allowed. Okay, we still have our 2 letters followed by our 4 numbers. The first letter, we have 26 options. Since we cannot repeat, there are only 25 letters to use for the second letter. There are 10 digits to use for the first digit or number. If it's the number 5, well, now there are only 9 left over, followed by 8, followed by 7. This comes out to 3,276,000 possible ID codes. Number 4, of 12 different songs, the local DJ is asked to play the top 5. And how many ways can this be done? This is a permutation because it's the top 5. It's not just the DJ's playing any 5 songs. Okay, to be number 1 is the best. So we could set this up as we have 5 songs and we are selecting 5. Okay, or you could do 12 times 11 times 10 times 9 times 8. Either way, we get 95,040 different outcomes. Number 5, how many different 11-member soccer teams can be formed from possible 25 players if any player can play any position? So this any player can play any position means that order doesn't matter. So this is 25, choose 11, it is a combination. We get 4,457,400 possible ways. Okay, number 6, this is a problem we've seen before. We're repeating it here. 7 boys, 7 girls are nominated for king and queen. How many ways can the king, queen, and her court of 2 be chosen? Well, we're only picking 1 king. There are 7 to choose from. We're only picking 1 queen. There are 7 to choose from. For the court, there are 6 girls left over. We are not ranking them and picking 2. So it is a combination. Now you could also set this up as being, well, king is a ranking, so order is important. Same thing with the queen. We still get 735. Or you could say, well, order doesn't matter because I'm only picking 1. So maybe you set it up as a combination for your king and your queen. Either way, all 3 of these options come out to 735 different possible outcomes.